Hey guys, welcome back to AlgoYogi. We are doing array and hashing series now, and our next problem in the list is time needed to buy tickets. So let's go to LeetCode and give this problem a read. So there are n people in a line queuing to buy tickets, where the 0th person is at the front of the queue, front of the line, and the n minus 1th person is at the back of the line. You are given a zero index integer array called tickets of length n, where number of tickets at the ith position is basically the number of tickets a person standing there needs to buy basically. And each person takes exactly 1 second to buy a ticket. A person can only buy one ticket at a time. That's the trick, and has to go back to the line at the end, and if they need to buy more tickets, right? Now, if a person does not have a ticket left to buy, the person leaves the queue. Regular rule, right? Like, it's a common sense. Now, return the time taken for the person initially at the position K. We will be given a position K to finish buying the tickets. So, a lot of words, but problem is very simple. There is, we are given an array, and that array basically represents the amount of ticket at the all these indexes people need to buy. So you can say at this 0th index, this person has to buy 2 tickets, this person has to buy 3 tickets, and this person has to buy 2 tickets. All right, and we are given K. K represents the index. So here this person needs to buy 2 tickets. We need to return the time this person is going to take to buy 2 tickets. K needs to buy 2 tickets, but it can't just buy it directly, right? Like, it needs to first let the front of the queue, it needs to come to the front of the queue, right, in order to buy the tickets. How? So this is what I mean. First, this is the person, this is the queue, this is the front of the queue, this is the front of the queue, and this is the back of the queue. This is like, this is just a scenario where this kth element is at the end, but that will not happen in all the cases, right? So let's say if this is the condition, and I'm going to mark this person now with different color, or maybe I'll just underline it. This is the person we are calculating the total time. So let's see how we're going to do it. Let's say time, I'm going to say time taken. Initially it's 0, then we will keep incrementing it. So if this is the person that I have right now, this is the person at the end of the queue, what will happen is this person, the 0th person, will buy one ticket, and will go to the back of the queue. So this guy right here, it will go to the back of the queue. So, and this will come in the front. Okay, so this guy will come in the front. 3 will come here. Our 2, this is the main guy. I will underline it. This is the main guy that needs to still buy. Now it's gonna come 1 position forward, and this 2 will become 1 now, because it already bought 1 ticket, and it will be basically, it will become 1, sorry. It will become 1. Great. So this is the situation right now. Now time taken is already 1 second. Why? Because this guy had to wait 1 second, although it hasn't bought the ticket yet, not even 1, but it had to wait to come to the front of the queue. So time taken is now 1. All right, time taken is 1 now. So this is no longer 0. Then in the next second, what will happen? This guy will buy and come to the back of the queue, and our guy will come to the front. All right, this is the guy, and I'm going to just circle it. This is the guy. All right, so now this guy will come 1 step ahead. 3 will go back, but it will become 2 now, because it already bought 1 ticket. Time taken becomes 2 now. Then this is the position where our guy is buying his own ticket or her own ticket. So this will again go back, right? So this one comes here, this one comes here in the front, then this 2 comes here, and then this goes to the back right here. No, it actually becomes 1 now, because we already bought 1 ticket. So it becomes 1 now. I will do every single thing to make it distinct. Now time becomes 3. Now tell me, in order for this guy to come to the front, these two will have to again, buy their own ticket and go back. So what will happen is I will move this thing right here, just here. So I will move this thing right here so we can continue our iteration. We can do one still. All right, so this will buy ticket to, then this one will come here, this will go as a 0 to the back, and we don't have to actually append it anymore because it became 0. Then we can just, like, this person will leave the queue, the queue will become this, queue will become this. All right, so in the code we will just skip it. We wouldn't have to do, like, we wouldn't have to change the array during the iteration. And this is a guy right here. Okay, sorry, I've changed the color here, but anyway, this is the guy. Now the time now is 4 seconds. Now it's 4 seconds. Then this will buy, why did I write it 2 now? Like, it was supposed to be, okay, no, never mind. This is actually the other guy. This is still 2. This is not our guy. Our guy is this. This is our guy. My bad. Okay, so this will buy the ticket, and then our array will become, 1, our guy, and then 2, and that's it. Now the time is 5 seconds, already done. Now this guy, our guy, is in the front, and it only needs to buy 1 more ticket, which it will do, and our array will become just 2, and our guy has bought 2 tickets. 2 tickets. That's the number it wanted to buy, and now it becomes 0. So we can just check out and return our time 6. So 6 is what we will return. A lot of things going on here, but let's dive deep into. So by the way, everything is very clear, right? So we just, whenever our position becomes 0, and we keep incrementing the time until our index becomes 0, not the index, the value at the index becomes 0. At the kth index, the value becomes 0. That means you are done buying all your tickets. Return the time that you have basically spent so far in the line. All right, so what will really happen in our code is basically we'll use a while loop until this position becomes 0, and you will run a for loop at the entire array, and if these positions, they are not 0 yet, then you will keep incrementing the time, and you will keep decrementing these values. So honestly, this will be actually really easy problem to code. Whatever we have discussed, the dry run, if we just implement it line by line, the thing that we have just done, that will give us our answer. So total time, I will just say 0, and I'll say while tickets at this index. What is that index? It's the kth index. If this is not equals to 0, then you are going to basically buy tickets for all the people in the line. So for I in range length of the tickets, what you will do is, if this guy at ith position, if this person still needs to buy a ticket, which means its number of tickets it needs to buy is still not 0, then you will increment your total time. Remember, this guy could still be our guy, K. We are doing it for everybody, okay? Because you have to go basically for the entire line, all the people, and then come back in the beginning, keep repeating it until this position becomes 0. All right, then you keep incrementing our time, and if ever this guy, maybe there was a situation, although we don't have to write this line, but it will actually be easy to actually just check return from here if our kth position becomes 0. So we have collected this guy has collected all the tickets, and then just return the total time. Great. Otherwise, even in the end, we can just return the total time. So that would be it, guys. Let's zoom out and try this on examples. I think it should work, and maybe I hope we didn't miss anything. Yes, we did miss. What did we miss? If this guy has bought its ticket, then we have to decrement its value by 1. And now, boom. Boom. Yes, that's what I'm talking about. Oh. Great. So let's write down the time and space complexity. Time complexity is going to be big of n. Will it be n? Actually, it's going to be, if n is the length of the tickets, so let's just say t into k, because you're going to run this for loops k number of times, and we can say where t is the length of tickets and k is given to us, so we don't have to write that. Space complexity is going to be massive. Great. Constant. Okay, done. That was it. Let's go back to AlgoYogi, mark this problem solved, and see you guys later in the next problem. Other than, bye bye.